Welcome everybody. In this video, we are going to look at an interesting method to write down a repeating decimal as a fraction. So let me fix the notation here first. For example, if you have a number that has the pattern like 0.3333 and so on, so the pattern keeps repeating itself with no definite end. The conventional notation is that we are going to express such a number as 0.3 with a bar over the number 3 to represent a repeating pattern of the number. Another example is that if you look at this number, if the repeating pattern is not all four numbers, but just the last two numbers here, so this number is like it keeps repeating itself with the pattern 3 2 without a definite end. So we are going to write down such a number as 2.1232, and the repeating pattern 3 2 has a line on top of it to represent that the only repeating part after the decimal place is the 3 2, not all the numbers here. Okay. Now the question is that how to write down such a repeating decimal as a fraction, and the method is pretty interesting. We look at the simple case first. So let's check out the case we just talked about, 0.333 and so on, which essentially means 0.3 with a line on top of it as the convention. So now, how to write down such a number as a fraction? So the method is that you let x be 0.3333 and so on, such a repeating decimal. And now the question is that you need to find a way to express x as a fraction. So how to do it? And let me try here. What is 10x? 10x becomes the number 3.33333 and so on, which essentially means that I'm looking at the number 3.3 with a line on top of the last 3 as a repeating pattern. So now you take a subtraction of these two numbers. What can you get? 10x minus x now equals 3.33333 and so on, minus 0.33333 and so on. So now the amazing fact is that on the right side, the repeating pattern cancelled out each other, so we get only 3 on the right side. How about the left side? We get 9x. So and then now I believe you can tell me that the fraction for x is 3 is divided by 9, and if you know how to simplify this fraction, it's the same as 1 over 3. Okay. So we arrive at the conclusion that 1 over 3 as a fraction is the same as a repeating decimal 0.33333 and so on. And this example is probably quite simple to some of you who are good at arithmetics. Even without this problem, this method, you probably know how to find it yourself without this method. And now let's look at some more complicated examples from here. So let's look at this repeating decimal, 0.1717 and so on, as the repeating pattern is 17 now. So how to do it? Let's follow the previous method. You let x be 0.17. 17 is the repeating pattern here for the decimals. And now, if you follow directly the previous method, you try to find 10x. It's not going to give you anything good because the decimals, the repeating decimals for 10x and x cannot be cancelled out. So now I have to choose 100x. You'll see the benefit of it a little bit later. 100x is what? It's the same as 17.171717 and so on. The repeating pattern again is 17 behind the dot. So now, same method. You take a subtraction. 100x minus x is equal to 17.17 as the repeating pattern minus 0.17 as the repeating pattern. So now the left side you get 99x. How about the right side? The right side, amazingly speaking, the two repeating patterns are cancelled out. So now what does it mean? It means that the right side now becomes 17 here. So you can do this calculation on your own, I believe. X is the same as 17 over 99. And it basically means that we are able to find the fraction 17 over 99. It is exactly the same as the repeating decimal, 0.171717 and so on. I don't think that this fraction is very obvious if you don't know this method. Okay, so let's look at the last example here. So now let's look at this more complicated repeating decimals, 3.4, and the repeating pattern is 212 here. So let us try to use the same method as before. We let x to be 3.4, 212, and the repeating pattern is 212 here. So now you have to multiply x by some numbers so that after the subtraction of this number with x, we get that the repeating pattern can be cancelled out. So now my choice is 1000x. In that case, you get that the right side becomes 3412 point, 3421.2, and then the repeating pattern now is 212. So and then we follow the same step here. We do the subtraction. 1000x minus x, it is equal to 3421.2, 212 as the repeating pattern minus 3.4212. So now please check on your own. Although the numbers behind the decimal cannot be cancelled out exactly, but we still can cancel out this repeating pattern, which is the most important thing we do here. So on the right side looks like 3417.8, and the left side 9998. So it means that now x is the same as a fraction 3417.8 over 999, and definitely for rational numbers we want both numerators and denominators to be integers, so you can multiply both by 10. So you get this number as the fraction you want. So as a conclusion, we get this one as a conclusion. I don't think this fraction can be easily obtained without using this method. Okay, so the last exercise for all of you to do is that please try to express these three numbers, repeating decimals, as the fractions by using the method of today's video. So that's the end of this video. Thank you everybody.